Hello, everyone, and welcome to today's webinar, Designing Cross-Sections and 3D Visualization using RSLog. Thank you for taking your time and being here today. My name is Alireza Afkhami, and I'm Product Manager of RSLog. Prior to joining Rocscience in 2021, I've been working as a geotechnical engineer for over 23 years. And that's how we started RSLog and adding more useful features constantly during the past 3 years. So in this presentation, we are going to review RSLog features for cross-section design and visualization. Please feel free to post your questions in the questions panel. And if you want to set up maybe a separate meeting with us, you have questions or you want to switch to RSLog, you need more information, you need to know how to migrate your data, please email us demo@rocscience.com, and we will be happy to meet with you and your colleagues for more detailed information. Okay, so with that introduction, we are going to start the webinar and talk about RSLog. So I'm going to give you a little bit of background about RSLog if you're not familiar with RSLog, just to see what it can bring to you. So some quick facts. First of all, no installation needed. And this is huge because you don't need to take the time from your IT team in order to install and deal with permissions and all that. The only thing you need for using RSLog is just a username and password. All the permission levels and all that could be handled by RSLog itself, and you can set it up for different users who can access which page in RSLog or which feature. And because it's a web application, the license is flexible. And what it means is that the license is not tied to a specific device. You can use your work laptop, and then you can use your personal computer to log in, or you can use tablet, log in, access data, generate different types of reports. As soon as you enter the data, the boreholes are on the GIS map, the boreholes and projects. There is a built-in GIS and map system with RSLog. And then we have 2D and 3D visualization. 2D, I mean cross-section design, which is the topic of today's webinar. And then we have a lot of customizations. So on the settings page in RSLog, you customize your borehole log template, for example. You can design your own, or you can customize the list of sample types or field tests, drilling methods, or isometers. There are a ton of customizations that you can do in RSLog. The most recent feature for customizations in RSLog that came out a few weeks back is uploading your user-defined patch patterns. So now you can design your own patch pattern and just upload it to RSLog and use it with your borehole logging. You have two different deployment models: cloud version, which is used by most of our users, and then there is on-premises version where the application RSLog and its database is installed on your own server. If you need more information, please contact us. We will be happy to help you. And of course, we have ongoing development. So those of you who are familiar with RSLog, you know that every few weeks we have an update, and you don't need, again, no installation needed. Next time you log in, you will see a new feature, you will see improvements and bug removals automatically. Okay, so an overview of RSLog features. First thing is that we have an app, iOS, Android app called OnSite that you can use for data entry during site investigation. It works on iOS, it works on Android, it works online and offline. We are going to add a bunch of more features, including handling photos and everything in the next couple of months. So make sure if you've used the first version of OnSite, please make sure you come back and see the new version. RSLog is already integrated with Settle3 and Slide 2. Settle3 is Rocscience's settlement and deformation embedment design program. And slide 2 is our slope stability, 2D slope stability program. I know most of you are familiar with these programs. So the integration, what this integration means to you is that if you have your borehole data in RSLog, then you don't need to re-enter that data in Settle. If you design your cross-section in RSLog, then you can simply download it and use the same geometry with the same type of material in a slide just in few seconds. So that's a huge time saver for you if you use a slide. Looking at RSLog itself, we have different data entry pages for projects and boreholes and cross-section design and lab tests and all that. You can import your data from GIMP, from Dix, and a couple other programs. In terms of exporting, your cross-section design could be easily exported to DXF and Civil 3D and to Google Earth. We are going to see a bit more details during this webinar. And then, of course, every single table in RSLog could be exported to Excel, CSV, and our own JSON format import and export features. CSV import is on the all of our tables. So if you have your data in CSV format, it's easier for you to import it that way. It's just one click away. And then different reporting features, borehole logging, of course. And then we have a very powerful GIS map. We can export data to many different formats. And then site location map and boreholes location map are all automatically generated by RSLog. So these are all things that save your time. And these are like day-to-day work for you. If you prepare your geotechnical report, definitely you can enjoy all these features. Summary report is something that we added back in Q1 of 2024, which is very useful. You can put all your project data in different tables, either in PDF format or Excel format, especially for projects with large number of boreholes and test results, lab tests and all that. This is going to save a lot of time. And now, of course, we have tools for borehole log template design and lots of settings and customizations. Okay, so with that introduction about RSLog, I should jump to the database design and some IT aspects of it that is going to serve you. So as I mentioned, the database, your RSLog database is in the cloud, and it comes with a lot of advantages. The main advantage is that all the users that are connected, that are logged in and connected to your RSLog account can see the same data, and that there's essentially their data is synced together immediately. So just imagine if you have two field engineers using our on-site app during site investigation. These two might be working on the same project or two different projects. As soon as they enter data, here the project manager sitting in the office or working from home, they can just refresh the page and they can see the latest data. So this is going to save, again, a lot of time because it makes team collaboration much easier for everybody, because everyone has access to the latest data. Some basics of cross-section design. These are the things that you all know, but I just wanted to put them in one slide. First thing is coordinates. So if you want to design your cross-section, you need coordinate for your boreholes. And these coordinates could be either geographic coordinate, or it could be northing, easting, right? So what RSLog does, it will convert northing and easting depending on your UTM zone or state plane coordinate data or settings. It would put all of these boreholes on the map behind the scene. In RSLog, we cover more than 7,500 different coordinate system. And these are under different categories of projected coordinate system, UTM coordinate system, geographic coordinate system, state plane coordinates. So pretty much all the coordinates are covered. Next thing you need for cross-section design is your subsurface soil conditions, soil and rock conditions. These are entered in RSLog. So again, once your data is in the central database, in your RSLog cloud database, all the other modules of RSLog, such as cross-section designer or the report, different report features, these are all connecting to the same database. So you enter the data only once, and then you can use it everywhere else, every time with the latest data. So the next one is the test results. If you want to show, say, your SPT data on your cross sections, or if you want to show, say, moisture contents or algebraic limits on your cross sections, it's very easy. It's just turning on and off one of these features and showing them as graphs. We are going to see some good examples of this. And then groundwater data. So groundwater data in RSLog, we have two different groundwater data. One is water level observed during drilling, and the other one is water level measured in the piezometer. Right. So both of them, you can choose which one you want to show on the cross section, and then you have full control on presentation of all this data in your cross section design. Another thing to keep in mind is local geology, and this is where your local experience and engineering judgment comes in. For example, if in your area there is a map showing the peak bucket locations or potentially liquefiable material or zones in your city, or unstable soils, a map like this can help you a lot, because some of these may not be encountered during drilling, but if you know that they exist, you can show them somehow and include them essentially in your cross-section design. And another thing is your field observations during site reconnaissance, or your observations in the nearby excavations, if you want to bring these to your cross-section design. So that brings us to this big question of whether cross-section design should be done manually or it should be done automatically. And I'm a fan of a manual design, in a sense that we don't want the program to connect the layers together for us and make a decision whether this layer should be connected to that layer in these two different boreholes. I think we should combine engineering judgment with your local geology knowledge and your experience to design the cross-section. What we do in RSLog cross-section designer module, we just give you some geotechnical tools to make it easier for you to design the cross-section. That's all we do, because we know exactly how the cross-section design works for you as a geotechnical or environmental engineer. Now, going back to the borehole data entry, in this screenshot, you see coordinate data entry. We talked about more than 75 different coordinate systems supported by RSLog. And then stratigraphy data, again, one record per layer. You enter this data for your borehole in RSLog. Field test, any type of field test that you want to show in the borehole log or in the cross-section, you can enter it here. You can customize the list of field tests, and also lab tests. So lab tests are entered on a separate page. And this is our groundwater data in the piezometer. One of the features that we are working on, and you should expect it in the next few weeks, is nested piezometers. So soon you will be able to add multiple piezometers to the same borehole. But in this example, you see that there are three different water level measurements in this piezometer, and you would have the option to show the soil level measurement in your cross sections. Now, traditionally, the way that you would do your cross section is that you would first go finalize your stratigraphy design and subsurface modeling in terms of the borehole log. So finalizing the soil layers and rock layers, combining layers or adding lenses, looking at the lab test data and finalizing. And then you would pass it to the drafting department. So your borehole logs go to the drafting department and they have to figure out where the locations are and measure the distance and put them on a cross section, then implement all the soil and rock layers, and then they would pass it on to you. So with your engineering judgment, you start connecting layers together. So what happens in RSLog, all these transitional works to transfer data to the drafting department, these are all automatically done by RSLog in no time. The reason is we already know the location, the coordinates of boreholes. We can easily behind the scene, we calculate their location. We have the elevations, we have the soil layers, and that's where RSLog can save you a lot of time. So if you are an RSLog user, in order to use the cross-section design, you go from the left menu, you go to data entry and design, and you click on cross-section menu here. And this takes you to this page. Click on the open cross-section designer, and it's going to open the cross-section designer for you. So one thing to mention is that last week we released an update, a major update to our cross-section designer. So if you are an RSLog user or you've been tried it before, I encourage you to go and use cross-section designer, the new version, and share your feedback with us. But this is the first page essentially when you come to cross-section designer. As you see here on the top right, we have three different modes. We have plan view, profile view, and 3D view. So we start with the plan view because it is where you can essentially draw or create your cross section on plan view. The first time you come here, there is no cross section, but you will see all your project boreholes here. You can zoom in. This is a map, similar to Google Map, except it's a GIS map. It's much more powerful. We'll see how you can customize this. But then on the right side, you see the list of cross sections that you already created. When you click on one of them, it will zoom in to that cross section. So if you want to know what features the map has, in addition to the map view, obviously you can change the style to satellite view and also the topographic map. Another feature that you have here, again, in order to customize it and relate to your project features, is that you can add shapes to this map to represent different structures or even underground utilities, or maybe you want to draw a polygon for your to represent your project area. So all this can be done by this toolbar to add shapes and lines and everything. And then you can give height to different shapes to represent buildings. Another thing to mention here is that you can import your project-specific data into this map. For example, if you have a Google Earth file that shows the outline of your project and different proposed structures, if you have it as a KML KMZ file, you can easily import it here to your map. There are other formats such as GPS Exchange and WKT and the basic version of land XML that you can import. You can also create cross sections by importing data from CSV. If you have the lat long of those locations, you can easily create those by importing. On the left side of the page, you see the property panel. So essentially, whatever you click on them here from the right, on the map, you will see its properties here on the left. In this example, we've clicked on building number 1, which is this shape, and you can change the coloring and size and transparency and all that. If I click on this cross-section, then I'm going to see the details of that cross-section. And here at the bottom, when you click on a borehole, it shows you basic information about that borehole, and you can see the list of soil layers and groundwater data and all that. Okay, so now another thing to mention here is that we have coupled machine learning engine with our cross-section designer. So powered by geozeta.org, they collect public borehole data. As far as I know, more than 200,000 public boreholes in the US are collected from different DOTs. And geozeta.org provides this data to us. So if your project is in the US, you're going to immediately after coming to the map page in cross-section designer, we load all the nearby public boreholes for you, and you will be able to include them in your cross-section design. Another thing that is available here thanks to geozeta.org is machine learning. So if you want to do that, if you want to get estimate of subsurface soil condition within your project area based on public borehole data, you just click on that button on the toolbar. It takes you to this page, and you can choose the distribution of the machine learning borehole. We call them virtual boreholes. So once you select the distribution and the number of boreholes that you want to add, after a few seconds, it will add these boreholes for you. You see in this example, the triangular symbols from V1 to V10. These are virtual boreholes that are added to your project area. And if you select one of them here on the left, you will be able to see the estimated stratigraphy in that borehole and estimated SVT data. Okay, so now another thing is querying borehole data in the cross-section designer. Again, I come back to the fact that all features of RSLog are always connected to the latest version of data. There is only one database, right? So when you are on the cross-section designer, you can have access to all your borehole data. You just select a borehole. Here from the list, you can select it, and then in this example, B64, and then you can see the subsurface soil condition. If you want to see what type of material you have here on the plan view, when we switch to profile view, you'll see a lot more. And then groundwater data as well. So you want to see if anything was observed during drilling or in the episode, you can easily see the data here. Now, one thing to mention, if you update this data in RSLog, say you or your colleagues open RSLog and they update this data. This updated data could be groundwater data, could be subsurface soil conditions, merging some layers or changing the interface between layers. Next time you come to the cross-section designer, even if you previously designed the cross-section, next time you load it, the cross-section design is updated to reflect your borehole data. Okay, so now let's see on the map, on the plan view, how you can create your first cross-section. The idea is that you click on the click on the add new cross-section, and then just start drawing the cross-section on plan view. Now, drawing this cross-section, you can connect boreholes together, or you can go in between boreholes. And as you see here, by adjusting the buffer zone, you can automatically include or exclude nearby boreholes. You can do that manually as well if you want. But this gives you the idea that what in this example, you see all these boreholes included in this cross-section are shown with their offset and distance from the beginning of the cross-section. You can change the coloring, and you can see more data. You can lock a cross-section so that you accidentally don't don't delete it or change the geometry of it. But what RSLog does, once you draw or create or edit a cross section, it will automatically project these nearby participating boreholes. It will project them on the center line of your cross section. You see here in this example, B57 is projected. Here, these boreholes are also projected. So when you switch to the profile view, you always see the projected location along the cross section. And if you come back, edit this, we will automatically calculate all those distance and offset for you. So when you switch to the profile view for a cross section, this is the first thing you see, and these are the stick logs. So just by coming this far into the design, you've saved hours and hours of back and forth with your drafting department, because everything is done automatically by RSLog. You have the stick logs based on their actual elevations that you entered during borehole data entry. All the soil layers are here. All components of this page, such as soil descriptions or groundwater data or SPT graphs, everything could be turned on and off just by using this property panel on the left. So the only thing you need to do is select an object, click on a borehole or click on a graph, and then start changing the coloring and font size and everything, or just turn on and off. So let's zoom in this corner just to see what we have here. So you see B64 is telling us that we have a 2-inch standpipe piezometer here, and this is the groundwater measured in this piezometer. If all your boreholes have piezometer, you will see them. If in some of the boreholes you observed groundwater during drilling, those are also going to be shown on the stick logs. We show groundwater during drilling. We show them with hollow triangle, and the piezometer groundwater level measurements are in solid triangle, like the example here. So that's the piezometer data. Again, we are going to add nested piezometer in the next few weeks if you have multiple piezometers in a borehole. And now in this example, you see a graph of SPT data for this borehole. You can add up to 2 different graphs to each borehole. Both of them could be field tests, or both of them could be lab tests, or you can combine. Let's say you want to have SPT on the left and you want to show moisture content, or pocket penetrometer on the right side of the borehole. Again, if you want to change any of the coloring and properties and font size, you can easily do that here by selecting that object. In this example, we just do that. Click on the graph. You see the graph is selected, and here you can change the properties. One of the things with graphs in cross-section designer is that you can change the presentation style of the graph, and it could be shown as a plot, as a graph, or it could be shown as a table. Some engineers prefer to show like SPT data, say either elevation and SPT below counts or with depths. You can easily do that. This is an example. Here is your test results. It could be any test, lab test or field test. Okay, so now we jump into how to connect layers together. In this example, you see we've went ahead and just connected layers together based on the soil descriptions or based on the default hatch patterns or representation of the soil types on the stick logs. And here I want to show you that, as I mentioned before, we don't do things automatically. We don't want to replace your engineering judgment, but what we have here is some very simple tool to help you save time. For example, you see this void here at the bottom of this cross-section for clay soil. So none of these are connected together yet. And I'm just showing you how easy it is. The only thing you need to do is to just go to the toolbar and click on this button here, and then click anywhere on the soil layers in different boreholes, like clay soils in all of these boreholes, and the program is just connecting them together automatically. When you're ready to end it, just click anywhere, and you see that now this layer is drawn as a clay soil layer here. And if you want to customize the way it looks, you can always add more points and just move the points to come up with the shape, and with something that is more presentable, realistic in your view. It could be adding points in between the boreholes and making them zigzag or what. And then you see here that you can assign different hash patterns to a layer and to a polygon after you draw it. You have USCS, ASHTO, AGS completely implemented in RSLog. So you have plenty of choices for your hash patterns, and you can change the pattern scale. You can make them denser if you want. You can change the coloring, and you can even switch between solid colors, between hash patterns and solid colors if you want. I just here show you that inclined boreholes are also supported. In this example, we have a tunnel with 5 boreholes. Even if it's not a tunnel in a normal project, you can easily have inclined boreholes. In this example, you see the cross-section is designed, and all of that is just by the same methodology that I explained, just connecting layers together. What you can do, you can also use this button here to draw a freestyle polygon. You see an example of it here. We drew a polygon and gave it a green color, gave it some transparency, and just added a text on top of it, called it contaminated zone. So that gives you the idea of how you can use the combination of lines and polygons essentially in this simple CAD tool in the cross-section designer to design and represent pretty much everything. In this example, it's contaminated zone, but it could be an underground tunnel. It could be maybe a box for utilities. It could be a line showing the proposed tip of the piles or proposed bottom of excavation. So anything you can add to this cross-section design very easily. This is going to be so that the main purpose of this tool is to save time for you and minimize back and forth between engineering and the drafting. You will see that you can export this design to DXF and just leave maybe some fine tuning and finishing touches and assigning maybe your own standard hatch patterns and putting it in title block. So typically, maybe 20% of the time that the drafting is spent on the cross-section design, they are going to spend because they just finalize the cross-section. Everything is done here when you're connected to RSLog database. Here we have this color scheme, which allows you to switch between hatch patterns and solid colors. Sometimes it's easier to see in solid colors if you're looking for a specific layer with a specific color, and this way it's easier to distinguish that. And then, of course, you can export the entire model to DXF. In order to export to DXF, you just go to the export menu here on the top toolbar, and then select the export to DXF. There are different settings here, and it takes a few seconds. We've improved this feature a lot in the past few months, so it's very quick, very fast to create your DXF model. And from that point, all the borehole location and the distance and everything is there in your DXF, saving a lot of time. You can also assign different horizontal and vertical scaling. There is a bunch of other features here that I let you explore by yourself in the cross-section designer. Another feature is exporting to Google Earth, and export to Google Earth. It's not limited to one cross-section, but it includes all the boreholes and all cross-sections of your project. So everything will be saved in a camel CamZ file, and it gives you a lot more flexibility. I have an example here under 3D visualization. So in this example, we've exported a project with 15 boreholes to Google Earth. And here I have a video that shows you. So we loaded that file in Google Earth, and you see the location of all boreholes with their soil layers, even the soil description. You can turn on and off all these from the left panel here in the Google Earth. But then if you turn on the cross sections, you see all the polygons for different cross sections in your project. These are all exported to Google Earth. And from this point on, it's just you can enjoy all the features that comes with Google Earth. You can zoom in, you can add, you can import other KMLs to overlay on top of this, and those could be maybe a geology map that you want to load, maybe a project-specific KML, CamZ that you want to overlay on this cross-section design. Okay, and another thing I want to talk about is the 3D view. So once you're done with your cross-section design, you will go to the 3D mode, and this is done here from the top right corner. You click on 3D, and here's what you see. You will see the location of all the boreholes and all cross sections that you design. And again, these are all connected together. If you go and change the cross section design, and immediately when you come back to the 3D view, you're going to see the updated design. The other components that we see here on this page is the map. So you see that in the background here, we've added satellite photo. You can choose between map, satellite, and then you can generate a terrain model essentially automatically in the cross-section designer without importing anything. And what we do, we essentially send the project site location to different map servers, and we obtain LiDAR data. Okay, here we are showing that you can turn on and off different cross sections if you like, or switch color scheme. But the idea is that we obtain LiDAR data, and we obtain elevation data in a grid line in your project site, and we can model the topography essentially in your project site. You see it here in this example, and then you can adjust it left and right, up and down, in order to match it with your project site. Another thing I want to show you here is that in this example, you see this geophysical test results. So this is electrical resistivity test results in this example, but it gives you the idea. So pretty much any type of test results that you want to add here, any type of geophysical test, the only thing you need to do is to export that test results, in this case, electrical resistivity, to a PNG file, to an image file. And then here, very easy, you can just click on the import button and just import it as a PNG. And then when it's imported to your 3D model, we have tools to scale it. We have tools to rotate it and move it around so that you can put it at the right location. One of the things that we are working on and in the near future, you're going to see this here is to import your own LiDAR data. Because the LiDAR data, the way that we generate this terrain model here is not the most accurate. It's just based on the public satellite data. But if you want to import your own LiDAR data, DEM files, and so on, soon you're going to be able to do that. And the last thing I want to mention is that the 3D model that you see here, you can easily export it to 3D formats such as wavefront object models or GLTF model, which is very comprehensive. It even includes object data, and this way you can share it with others, either with your clients or maybe if you want to prepare a proper 3D presentation of your site, you can easily import these into other programs. Okay, and that brings us to the end of this presentation. What I suggest is that if you're an RSLog user, please go ahead and try the new version of Cross-Section Designer. But if you're new to RSLog, we would be more than happy to meet with you. Please email us and we set up a meeting. We talk about how RSLog can help you with borehole logging and borehole data management. RSLog is definitely more than just borehole logging. As you see, we have GIS system, we have different reporting features, and we are going to add more and more features to RSLog. Data migration is one of the things that a lot of consulting firms are worried about, but we can help you with that. Please contact us. Let's have a one-to-one personalized meeting and answer all your questions. So at this stage, I'm going to see if there are any questions. I'll be happy to answer those questions. So, maybe I pass the floor to you.
We have a bunch of questions. I'll start with the first one. The first question is from Mark, and he asks, can you import data from AGS data?
Yes, yeah, very good question. So AGS, we have actually a Microsoft Excel add-in for AGS, for handling AGS data. So if you work with AGS, please make sure you contact us. We give you the instruction. It's actually on our documentation website as well. And that Excel add-in helps you editing AGS data, generating borehole log, and exporting to AGS format. One of the things that we are working on right now is to essentially connect our Cross-Section Designer to your AGS projects. We are still not there, but we are working on it. The AGS data should be converted to the right format before it's viewable and usable on the Cross-Section Designer. But keep checking back during the next couple of months, and you will see a connection of AGS Cross-Section Designer.
All right. The next question is from Mark again. He asks, can RSLog interact with OpenGround?
Not at this stage, and we haven't had a lot of requests for this. But we have, like in terms of exporting data, if you want to transfer data from OpenGround to RSLog, we can help you with that. We have some third-party companies who can do that conversion for you, and if not, we can help you to convert your database if you want to switch from RSLog to from OpenGround to RSLog. One of the things that we worked on is that previously OpenRoad had an import from Excel. We have that feature. If you have an older version of OpenRoad, you can export all your data into that older version of OpenRoad, and this way you can transfer the data to OpenRoad.
Okay. The next question is, can you view the shapes when you are using 3D mode?
In 3D mode, not yet. And that's a good question. Not yet, but that's something that we are working on for the near future. It's not difficult. It's just the fact that we recently added these shapes to represent like structures and utilities. So this is a fairly new feature that just came out last week. But soon you are going to see those also in the um, in the 3D view.
Okay, next question is, how do I remove the sandpipe piezometer stick if I do not want to see it in my cross section?
Yeah, so it's very easy. You just go to groundwater options. So on the left property panel, there's a property called groundwater options. You click on that, and then you click on hide piezometer. So that's a relatively easy thing to do. You see it here. So if you want to hide the piezometers, you just click on groundwater options and click on hide, and it's going to hide your piezometers.
Okay, the next question is it possible to import a topographical surface that can be interrogated along each geological section?
Yeah, so as I mentioned, you're working on importing LiDAR data. We are also working on importing two other things. One of them is the point cloud data, and the other one is importing CSV data for the essentially a collection of ground surface elevation points that are measured, so X, Y, and Z, and then we generate a mesh based on that data set. I expect that in the next 4 or 5 months, we are going to have all of these features in 3D view or 3D view and of cross-section design.
Okay. Is the cross-section designer preloaded with British standard borehole legends?
Yes, yeah. So all those essentially. So to answer this question, I have to say that in RSLog, as I mentioned, we have USCS completely implemented, AGS implemented, and Ashton implemented. And if you go to the settings page in RSLog, go to the hatch design tab, you will see the list of all these different types of hatch, right? So the same hatch patterns are used in the cross-section designer. The new version that came out last week, it allows you to upload your own hatch pattern. So now in the settings page, hatch design tab, there is a new tab called user defined hatch, and you can upload your own. You can design your own image, save it in PNG, and then just upload it. We are working on bringing that user defined hatch in the cross section design, and that way, very easily, you will have a lot of options essentially with your cross section design. But remember, most users just design the cross section here in RSLog and then export it as DXF. And then with that DXF, when you load it in AutoCAD, you will have like full power and full control on using your own hatch patterns, right? Because and the critical part that takes a lot of time is measure the distance between boreholes, put them on a drawing, with their actual elevation, with all the soil layers, with all the lab tests and field tests that you want to present in the borehole lot, in the cross section. So that part is done in the cross section designer. If you want to change the hatch patterns, it's just simple drafting that you can do after exporting to DXF.
Okay, the next question is, can you include SPT n value next to all stick logs, just numbers and not charts or tables?
Yes, yeah. And I believe we showed in one of the slides, we showed that. So the SPT are essentially any test data could be shown either as a graph or as a table. And I think I have it, yeah, stick log. So in this example, you see that SVT is shown as a graph. But then in the next slide, I'll show you that if you select this, then there is a property called display options. So when you click on display options, you can choose the presentation style table. And if I click on table here, you can see the numbers here, right? So a couple of things here, just because this question is asked, you can choose whether you want to show the depth or elevation or both of them in the table. The other thing is that, as you know, field tests, each field test can have multiple data column, right? And you can choose what data column should be displayed or should be plotted in the graph. So all of these are done in this property grid. You'll have full control on what needs to be shown, in what color, in what font size, in what format.
Okay, next is, can you display a CPT log next to a borehole?
Yes. Yeah, you can. So it could be SVT, it could be CPT, it could be anything. We are right now, you can show one test per plot. So say if you have CPT, you want to show QC and FS, you can put QC on the left and you can put FS on the right side. Another thing to mention is that we recently added a feature that you have a new type of reporting in RSLog, which is called SVT/CPT report. And that is essentially in your title block, you can plot SPT or CPT or both of them with your hash patterns column and a stratigraphy like as lithologic description. You can use that option as well, or if you want to show it in cross section, you can definitely do that.
And the last question is, can you use RSLog for tunnel cross sections, input tunnel 2D geometry within the cross section?
Okay, to import to the cross section. So on this page, on the profile page, there is an import button, and in the import button there is import from CSV. If I'm correctly understood the question, if you have those coordinates for different polygons and layers that you want to show, or an underground utility or anything, if you have those coordinates and as X and Y, you can import it as a CSV file and it will be automatically added here. So that's going to save some time if you are dealing with some complex type of underground structure or ball structure. Instead of clicking point and point, you can do that, save it in CSV and import it. I'm hoping I've understood the question correctly, but regardless, please make sure that you communicate with us. You can always email us if you want a demo or if you have more questions. We'll be more than happy to meet with you and ask any question. If you want training for your engineers to use RSLog or to evaluate RSLog, we can help you. We can even design your Borehole log templates for you if you want to switch to RSLog. So please keep the communication line open, and we are here to help. And thanks very much. If there are any other questions, please email us, demo@rslog@rocscience.com or support@rocscience.com. Thank you very much.